Audiobook Academy Biography presents William Herschel. British astronomer and physicist Sir William Frederick Herschel, or Friedrich Wilhelm Herschel, November 15, 1738, August 25, 1822, was the creator of sidereal astronomy for the systematic observation of celestial bodies outside our solar system. Uranus was one of his many discoveries, along with the idea that nebulae are made up of stars, and his theories on stellar evolution. In 1816, he was made a Knight of the Order of the Bath. Early years. The young man joined the Hanoverian Guards Band, where he played in the same capacity as his father. In 1757, during the French conquest of Hanover, he fled to England, where he first made a living by duplicating musical compositions. In the meantime, he worked hard to advance his career as an organist in Bath's Elegant Church, where he was appointed in 1766. By this point, he had developed an intellectual curiosity for music theory thanks to his father, and he turned to Robert Smith's harmonics for guidance. A complete system of optics by Smith served as an introduction to telescope building procedures and whetted his thirst for stargazing. Unlike most of his contemporaries, William was adamant about studying celestial bodies far beyond our solar system. Recognizing that he would need telescopes with large mirrors in order to collect enough light, he enlisted the help of local opticians, who were unable to provide him with the equipment he needed. In the end, he had to grind the mirrors himself. Copper, tin, and antimony metal discs were used to grind them. Even he had to admit loss in 1781 when he attempted to cast molten metal into discs in his basement, but the first mirror cracked on cooling, and the second attempt was a failure, so even he had to admit defeat. Finally, he was able to construct enormous, high-quality mirrors that were even better than those used at the Greenwich Observatory. Among the several eyepieces he created were the most powerful, with a magnification of 6,450 times. He was assisted by his brother Alexander, who had traveled from Hanover, and his sister, Caroline, who was his constant companion during much of his life. People in the scientific community began to hear about it. He conducted 2 preliminary sky surveys using telescopic lenses. During his third and final survey of the night sky in 1781, William made the startling discovery of an object that he understood was not a typical star. It turned out to be Uranus, the first planet to be found since the dawn of human civilization itself. William shot to stardom in the blink of an eye. A close friend, Dr. William Watson, Jr., presented him to the Royal Society of London, which awarded him the Copley Medal for the discovery of Uranus and elected him a Fellow. A £200 annual annuity from George III was also secured for him in 1782 thanks to Watson's intervention. As a result, he could give up his singing career and devote himself entirely to astronomical research. The Herschels relocated to Datchet, near Windsor Castle, around this time when William was appointed an astronomer for George III. As a professional astronomer at the age of 43, William labored tirelessly to compile a natural history of the stars. The nature of nebulae, which appear as glowing patches in the night sky, was a basic problem for which Herschel's large telescopes were well suited. Some astronomers assumed they were nothing more than a cloud of countless stars, whose light blends together to provide a milky look. According to some astronomers, certain nebulae are made up of a luminescent fluid. He soon discovered that his most powerful telescope could resolve into stars numerous nebulae that appeared milky to less well-equipped viewers as William's interest in nebulae developed in the winter of 1781-82. In his mind, increasingly powerful telescopes would allow him to see individual stars and other nebulae. It was this inspiration that propelled him to assert in 1784 and 1785 that all nebulae were composed of stars and that a mysterious luminous fluid was not required to explain the observable facts. Since they appear large to the viewer, the true size of unresolved nebulae must be enormous, he reasoned. They must be faraway systems, potentially larger than the solar system itself. As a result of this logic, William came to believe in the concept of island universes, or star systems. Theory of the evolution of stars. It was obvious for William to highlight the distinctions between these star clusters by comparing a cluster of densely packed stars with others in which the stars were spread out. These structures demonstrated the presence of attraction forces, and he predicted that over time, a large number of widely spread stars would gather into a few dense clusters. To put it another way, a group of stars that were more widely dispersed was at an earlier stage of development than a group that was closer together. As a result, William introduced the idea of change over time as a foundational tenet of astronomy. A cosmogony, or theory of the creation of our world, was created by him in 1785. The stars were originally distributed over boundless space, which attracted forces progressively ordered them into more fractured and tightly packed clusters. Then, He turned his attention to the star system in which the Sun is embedded and attempted to establish its form based on two assumptions: 1. That he could see all of the stars in our system with his telescope, and 2. That the stars inside the system are evenly spaced. He was forced to give up both of these preconceptions later on. This work provided the first important example of how stellar statistics may be used to estimate the galaxy's star system's spatial extent by counting the stars. Observers with larger telescopes, shut off from William's evidence, or hesitant to follow his daring thinking, could only watch in pity or disbelief. They first settled in Old Windsor in 1787 before relocating to Slough the following year, where William would spend the remainder of his days. In the companionship of Caroline, he examined the sky night after night, whenever the moon and the weather permitted. William had a watchman stationed in the yard to alert him if the clouds parted. Caroline would often explain their findings during the day while he worked on building telescopes, which he sold to augment their income. A 122 cm diameter, 48-inch, diameter speculum metal mirror, with a focus length of 12 meters, was his most burdensome tool, 40 feet. It was a technological marvel when it was finished in 1789. William's success in a field in which he became a professional only in middle age was made possible by his entire dedication and Caroline's loyal support. Until the death in 1786 of a friend and neighbor, John Pitt, and the subsequent marriage of John Pitt's widow Mary, he does not appear to have given much thought to the prospect of marriage. Shortly after, he proposed marriage to Mary in the Pitt home. Caroline would stay at Observatory House in Slough. As a result of this, Mrs. Pitt was well aware that William's dedication would be to Observatory House, where they made their primary residence following their marriage on May 8, 1788. When his health began to suffer from the strains of astronomical observation, William began to appreciate Mary's judicious management of his household more and more. Nebulae structure theory. At the end of November 1790, William's great theory of stellar structure was put into jeopardy by the discovery of an astronomical phenomenon known as the luminous fluid. Previously held beliefs were challenged by this revelation. While using his most advanced telescopes, even William believed that nebulae that he couldn't resolve, separate into discrete stars, might be distant island universes, what are now known as galaxies. Even with this new information, however, he was still able to alter his original idea and come up with the conclusion that the center star he had witnessed was condensing out of the cloud it was in. In 1811, he pushed the timeline of his cosmogony back to a time before the formation of stars was ever contemplated. William's thinking is exemplified by this particular example, a wealth of data analyzed through the use of audacious yet risky assumptions. According to his theory, all stars are equal in brightness, hence discrepancies in apparent brightness are just an indicator of the distances between them. It was a constant battle for him not to notice the mounting information that refuted his assumptions. To replace the 100 or so Milky patches previously known, Herschel spent 20 years systematically searching for nebulae, 1783 to 1802, and came up with 2,500 nebulae and star clusters. His work also included cataloging 848 double stars, stars that appear close together in space, and determining the relative brightness of them. Double stars, he found, did not form by coincidence, but rather revolved around one another due to the random dispersal of stars in space. Among his 70 published works were studies of the solar system's travel through space and the declaration in 1800 that infrared rays had been discovered. Thank you for listening in Audiobook Academy. Don't forget to subscribe and smash that like button for more content like this. See you in next video.